Welcome back to Calculus AB. This is Mr. Marth again. Topic 1.8, determining the limits of using the squeeze theorem. So today we're going to be talking about trig limits and we're using the analytic approach. Before we discuss trig limits, we first must familiarize ourselves with the squeeze theorem. So the squeeze theorem, if h of x is less than or equal to f of x less than or equal to g of x for all x in an open interval containing c, except possibly at c itself, and if the limits as x approaches c of h of x is equal to L, and the limit as x approaches c of g of x, right, is equal to those two as well, then the limit as x approaches c of f of x exists and is also equal to L. So what this is telling us is that if we have two functions, g and h, and then f is sandwiching between those two or equal to those two, and then if we know that the limits of both g and h, right, they're equal to each other, that means that the limit of f of x will also be equal to L. So pretty much we're going to be using, they use this theorem to prove that the limit as x approaches 0 of sine of x over x is equal to 1. Because if you do direct substitution here, you get 0 over 0. And also the inverse of that, so the limit as x approaches 0 of x over the sine of x is equal to 1. And the limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. And also for the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. So there's a limit right here, the proof of the special trig limit for number 1 for the first part. So you guys can go ahead and read it, see what's going down, see how they actually do it, right? You multiply and so forth. All right, but I do want to make sure, like, what I want to prove to you guys is how we use that limit. And the first example right here we have is the limit as x approaches 0 of the tan of x over x, the tangent of x over x. So let's rewrite it over here. The limit as x approaches 0 of tan of x over x. Now, I know that if I pretty much try to plug in 0 into this, I'm going to run into trouble, right? So I'm going to be running into 0 over 0, which is in the indeterminate form. So in order for me to be able to find this limit, what I'm going to do is that first I'm going to pretty much rewrite tangent of x, because I know that's equal to sine of x over cosine of x. So I'm going to take advantage of this trig identity to actually prove this. So this is going to be equal to the limit as x approaches 0 of the sine of x over cosine of x, and then everything divided by x. So I just replace tangent of x with whatever with the other trig identities it represents. And then here, right, I can continue. And pretty much like I can rewrite this as the limit as x approaches 0 of the sine of x over cosine of x times 1 over x, right? So remember the keep, change, flip. You keep the first one, you change the division, and then you flip this one. That's why you get with the 1 over x. So this, if we continue on, I'm going to change the order of some things right here. So the limit as x approaches 0 of the sine of x over x, right? So I just changed, I'm going to swap these two times the limit as x approaches 0 of the cosine of 1 over cosine of x. And then from there, we can see that the first part is, we know it's already been established, it's equal to 1, so I take advantage of that. And then times, the limit is of 1 over cosine of x, if you do direct substitution right there, cosine of 0 happens to be 1, so you're in the safe zone right there. So 1 over 1, so therefore my answer is just positive 1.